Hello students, welcome to JSM Learn. In this today's video, we are going to learn some of the previous IIT JEE Main questions and their solutions particularly from the chapter Thermodynamics. So from the concepts we have selected here, First Law of Thermodynamics and applications of work done. So let us see the first question, students. So here the first question on screen you can see. So they have given here as gas A undergoes change from state X to Y. So they are saying some gas is there, gas A, which is changing its state from X to Y. In this process, the heat absorbed. So that means Q is positive. So heat absorbed and work done by the gas is 10 joules and 18 joules respectively. That means Q value they have given here as what? 10 joules. And work done by the gas in this process. That means W is equals to minus 18 joules they have provided to us respectively. Now gas is brought back to state X by another process. Okay. So that means cyclic process they are mentioning about by another process during which 6 joules of heat is evolved. 6 joules of heat is evolved. That means Q value they have given as 6 joules. In reverse process of Y to X. So in reverse process of Y to X, which among these is correct we have to identify. So whether 18 joules of work has done by the gas or 2 joules of work has done by the gas or 12 joules of the work is done on the gas A by the surroundings or 14 joules of the work is done on the gas A by the surroundings. Which among these is suitable for this process? So let us see here X is converting into Y in the first process. Again in the reverse process Y is converting back to X, means completely a cyclic process. So as we know, in a cyclic process any of the state functions will become as what? 0. So if you see, according to first law of thermodynamics, we can write as what? Delta U is equals to Q plus W. So here for the first process X to Y, delta U we are identifying when gas A is moving from X to Y. So delta U value will get, Q value is 10 and W value is minus 18. So that means delta U we got here as minus 8 joules. So whereas in reverse process, as this whole process is a cyclic one, so complete change in internal energy for a cyclic process. In a cyclic process, state function value will become as what? Delta U here will become as 0. That means in reverse process, delta U, when the gas is coming from Y to X, its value will be what? Minus 8 in the forward direction. So first process, so now it will be plus 8 joule. So now again here they have given how much heat has evolved by the gas, minus 6 joules. When Y to X it is converting. So now here we can write the formula as what? According to first law of thermodynamics, Q plus W. Now this value is 8 joule. Q value they have given as minus 6. So we have to identify the work. The work value will get it as 6 plus 8, 14 joules. Okay, 14 joules of work is done on the gas by the surroundings. So option D, 14 joules of the work done on the gas A by the surroundings. So option D is correct in this question. Now let us see the second question. Here we have to arrange the following isothermal processes. So isothermal process, that means T1 is equals to T2. That implies there is no change in temperature. Delta T is equals to 0. Isothermal process. In order of the magnitude of the work PV involved between state 1 and state 2. So here some 4 different processes they are given. So now choose the correct option. So finally we have to identify the order of magnitude of work. So first one, expansion in single stage. WA they have mentioned. And second one, expansion in multi-stages, WB. Compression in single stage, WC. And compression in multi-stages, WD they have mentioned. So we have to identify. Now, to understand it in a easy method, I am drawing here some of the graphs related to this. First one, expansion in single stage. So PV graph, if you draw, expansion is taking place in single stage. So as a result of expansion process, pressure is going to decrease. As a result of it only, volume will be increased. So pressure has decreased, volume has increased. This is what expansion in single step. Now the second graph you can see here, expansion in multi stages. Expansion in multi stages. So pressure and volume. For the second one it is expansion in multi-stage, means here I am considering at least 2 steps. So first step, pressure has decreased, as a result of it volume has increased. Again second step, pressure has decreased, as a result of it volume has increased. So 2 step. Now multi-stages we are considering as 2 steps. So next third case they have given compression in single stage, WC. Compression in single stage. So here third graph, compression they are mentioning, pressure versus volume. So in case of compression means pressure has increased, as a result of it volume is going to decrease. Compression process. So compression in single stage. Next one, fourth graph they have given here as compression in multi stages. So if you see, compression I am taking in 2 steps again. So pressure has increased, as a result of it volume has decreased. First step completed. Next second step, pressure has increased, as a result of it volume has decreased. Okay, so now let us see all the comparisons in between the work done. So first one they have mentioned here as what? WA. So first one WA. Now the second one they have given here as WB. So the third one is WC, and this one they have considered here as WD. Now if you observe in these, by looking at these graphs, we can see area covered under the graph will give us the work done in this process. So here the work done in the first one, this much area is covered. Okay, WA. So now if you observe here, in the second process, this is the area covered under the graph, WB work. Now in this case, this is the area covered under the graph, WC we got. Now coming to fourth process, this is what the area covered under the curve. So now just look at it. First, where area covered under the graph is higher, that one will be work done will be higher one. So WC we can see excess work done in this process. So here I am writing WC is going to be very larger in the magnitude. Afterwards you can come across WB and WD. So by looking at the graph itself you can easily identify where the work has done maximum. Okay, so now if you see compression place, so in case of fourth one, compression in multi stages, and second one, expansion in multi stages. So both graphs seems to be similar only. Both the graphs seems to be similar. But as you can see here, P external has to be applied very higher comparing to the gaseous pressure, P gas plus dP. Okay. So now in case of expansion, P external will be slightly lesser comparing to the P gas by dP value. So in case of compression, where additional pressure we are using here, so as a result of it, compression work magnitude is going to be higher comparing to the expansion. Compression, this one is what? Expansion. So in case of expansion, work done is in comparison with the work done in compression process is little lesser. So W D, next one comes WB, the final one where very less work has performed in the first case, WA. So now you can see option WC, WD. Okay, so option B in this case is the correct answer. So now let us see for the next one. Students, here the question they have given related to match the list 1 with match the list 2. So now here first one, isothermal process they are saying. So as we know, isothermal process where delta T value will become as 0. So now for that expression we can write as, according to first law of thermodynamics, delta U is equals to Q plus W. From here Q is equals to minus W. Now let us come to the first one, reversible expansion. So for the first one, reversible expansion means work done we can write in this W. Reversible can be written as what? Minus nRT ln V2 upon V1 or V final upon V initial. So here you can see Q is equals to minus W. That means from here we can write Q expression is equals to, nRT ln V2 upon V1. So here it is matching with Q. Q is equals to nRT ln V2 upon V1. That means A is matching with Q. Now let us see the next one, free expansion. So in free expansion you know that delta U will become as 0, delta T will become as 0. Okay, no work done in that process. So as a result of it, Q is going to be equal to 0. So now that means for second one, so here you can match B is equals to what? Equaling with Q. Now the next, see, irreversible compression. So firstly, irreversible work done expression if you are writing W irreversible is equals to minus P external into V2 minus V1. V2 minus V1. So here related to this expression is here P external to V1 minus V2. So why? Because in compression case, final volume is always lesser than initial volume. So if you are taking out minus common out, so what it comes, minus of minus plus P external into V1 minus V2. V1 minus V2. That means here C, irreversible compression is matching with W is equals to P external into V1 minus V2. C is R, it is matching. So now the next one, so D, cyclic reversible process. In a cyclic process, all the state functions will become as 0. So here which is indicating us this expression is for what? Delta S. So here we can write delta S is equals to what? Q reversible upon T. So in a cyclic process this value will become as 0. So that means here D is matching with S. So let us see P. So QPRS. So QPRS. Here in option C, correct one it is. Now let us see the next question, students. Here one practice question for you. Give your correct answer below in the comments. Now let us go for the next question. So in the fourth question, here they have provided with some graphs. So which of the following graphs between pressure P in bar they have given versus volume in liters representing the maximum work done. So as we have seen earlier also, same type here also we have to identify the work done. Okay, area covered under the graph. So here this much area has covered here. Okay, so here in the second graph B case, this all the work done it is giving us the information. Now here this much work has performed in this cyclic process. Now here this one, by looking at it easily you can say this is a isochoric process. No work has done in this process. So W will become as 0. So where the work done is maximum, so directly you can identify among all these. area under the curve is maximum for case B. So here, this is the correct answer you can see. So like this, you can easily solve the questions related to thermodynamics topic also. So thank you all.